All right, greetings. What's up, FMS? How you guys doing today? I recognize a few faces out here. Day 2 of the big show. Happy to be here. So let me get on with my talk. We're going to be talking about unlocking the full potential of Flash in the AI era. AI, nobody's using AI in their title today, though, right? So we're unique in that regard. So that's the good news. So again, I'm Jim Elliott. I'm the newly joined EVP and CRO here at Sandisk, and we have 3 speakers today. As Jay mentioned, Mrinal Kocher is going to follow me. He's our SVP of Engineering. And then Alper Ilkbahar is our EVP and CTO. He's going to bat cleanup for us here this morning. So without further ado, let me jump in. So really excited to be here as part of what we call Sandisk 2.0. And the timing of this, it's a split from the brand new separate entity now for 6 months now. And the timing couldn't be better to be talking about Sandisk 2.0 with the advent and the onset, the dawn of the AI era. You think about these technology or IT growth drivers that have driven the IT industry over the last year, several decades. Every time you get into a new era, it's an order of magnitude larger than the prior. So we're very excited to be here, and the timing of this is perfect. We're very proud of our product portfolio, span the entire section of IT. On the consumer side, every form factor and density. The embedded side for automotive and for mobile. For client, both gaming and for mainstream PC. In fact, we have the fastest performing SSD in the market right now, the SN8100 series. And then, of course, on the cloud, where we have 2 main swim lanes. One is on the compute side. The other one is on the storage side, focused on data center. But the good news is both TLC and QLC go across the entire portfolio stack. TLC obviously enabling performance, QLC enabling capacity. So, users are racing to AI, but why is this happening? AI is racing to performance. So you think about the number of years that it took users, 100 million users, to break into some of these platforms. Netflix, it took them 10 years. Facebook, I think we called it the Facebook back in the day, took 4 years. ChatGPT happened in 2 months. Well, why is that? Because it's very human-like. All of these chatbots can now start to pass the Turing test. Even in the first 2 months, the Turing test was only passing that 25% of the time. Now it can pass it 73% of the time, whereby a human mistakenly thinks the AI at the other end is another human, when in fact it's AI. And I think this is going to continue the proliferation of AI because of this. You hear a lot about the AI arms race, right? A lot of CapEx being spent, but it's more than just CapEx. So the numbers are big. They continue to move up and to the right. You can see the data center CapEx spending boom. But now it's something different. It's all about the list. You guys, this is a hip crowd, right? You guys have heard about the list, right? There might even be some people in here that are on the list. This is that secret file of AI geniuses, right? These are people that are getting paid more than $100 million to join companies. And what's neat about this for me is these people are now being paid more than professional sports athletes. So now our industry is finally getting its due, right? Where we're able to hang out with some of the ballers. So I like the fact that the IT industry is getting its recognition here in AI. So good for us, the collective we here. Let's talk about some of the AI tools transformations as well, from prompt to purpose. So right now, an AI chatbot, for example, it really just talks about the current session. It's all it is. Short-term memory. There's no historical context. It doesn't matter. It doesn't remember the conversation you had with it yesterday or last week. Each interaction is independent. So what that means is you guys are really getting the 51st dates experience, right? This poor lady, she has amnesia. She can't remember anything. It's just kind of like when you talk to ChatGPT. It doesn't remember anything from the day before, and you have to start all over from scratch the next day. But the future, it's all about persistent memory. So you can see where this is going, right? It remembers your previous sessions. It knows the context. It knows your behavior? Do you use business English, colloquial English? Do you like to swear a lot? Do you not like to swear a lot? It's going to vibe with you. It's going to be your proactive AI personal assistant. Maybe it links to your calendar, to your apps, to your email. Think of that as your AI wingman. So you're going from that 51st Dates experience to that AI wingman that's going to help you along the way in business, in career, in education. But the key here for the industry is this drives an increasing need for fast storage capacity, meaning flash and NAND will become more essential. Now let's talk about the data creation piece of what's happening here. And there's a lot of talk about multimodal AI. But this is important, right? It's beyond text to text. Everyone's familiar with that. Moving into text to image, and then even voice to voice. And this is like full duplex voice. This isn't like talking to a robot in the 1980s. This is like AI interjecting and you guys interrupting each other and having more of a natural conversation. But the real killer app for this, and what's going to create this data deluge, is this, what I like to call the democratization of content creation. It's not just the big Hollywood studios. It's anybody with access to these types of AI tools can create studio quality product. So about a month ago, this trailer dropped. It's called The Untold, The Immortal Blades Saga. 100% AI generated and disruptive to the core. So no longer are we dependent on Hollywood to be able to create this type of movie experience for an audience. This is basically in the hands of billions and billions of users that can create, store, save, and leverage this type of content. So very exciting things to come. Okay, power. The power is becoming more and more of an issue. If you look at the slide, obviously it's up and to the right. It's about 5x for US data centers in aggregate, but it's about 31x for AI-specific data centers in the US over the next 10 years. Unfortunately, the US is not known for its prowess in adding electrical or electricity capacity. Nukes are being stood up, but bogged down with paperwork, takes a long time to do that, so the supply growth is quite flat. And as you guys are all experts in the memory industry, you know what that means from a price standpoint. Pricing costs for electricity are going up. So every watt saved is a watt then that can be redeployed elsewhere for your IT infrastructure. And so how do we get more efficient with the storage and the IT that we have? So that leads me to my concluding thought here, which is these universal laws are changing, right? AI data centers demand new storage metrics. So in the past, obviously, it was the theory of relativity, E equals MC squared, that governed our entire scientific community. But for data centers, we would like to propose a variance of that, IOPS per terabyte per watt. IOPS a proxy for performance, terabyte obviously a proxy for capacity, watt, how efficiently are we using that performance and that capacity. Now, if only there was someone really, really smart that could drill down and go into more detail on this. Hey, Mrinal, look at that. Looky here. So I would like to introduce our next speaker, Mr. Mrinal Kochhar, SVP Engineering. Come on up, Mrinal. There you go, buddy. How are you?
Thanks, Jim, for the compliment. I wish I just had two of his attributes, his hair and his intelligence. But I'll go with the mustache now. It's great to have Jim at Sandisk. I'm sure the Sandisk brand will do wonders under him, and he'll take it to the next level. I just need to deliver him the right products, which I'll show you in the next slides. But unlike Jim, I've been here a long time. I was here in the era of Sandisk 1.0. And with Sandisk 2.0, it gives me great energy and enthusiasm on our renewed focus on flash innovation at this pivotal time of the AI era. So let's dive into it. The AI workloads are causing a bifurcation, not only at the NAND level, but also at the system level, at the SSD level. Jim talked about cost of power, which is very important that we make the modern data centers efficiently utilized at full performance. But what is more important is the power piece of it. Let's take a step back and think about the traditional SSDs. The traditional SSDs were all about performance at any cost. Recently, we saw QLC getting into the mix of it. That was about density, but the name of the game was still performance. The TLC and QLC SSDs were serving the same purpose by different media management. You can think about it like two sides of the same coin. But now, with the AI workloads in the AI era, we see two distinct classes of SSDs. One, the compute SSDs, which are GPU attached, the TLC based. Name of the game, IOPS per watt. The other, the storage SSDs, which are network attached for the fast data lakes. Name of the game, IOPS per terabyte per watt. So let's dive into these. Let's start with the storage SSDs. This is my favorite slide. I am so happy to announce the Sandisk 256 terabyte drive in the latest E2 form factor. Do we have it in the other form factors? Why not? We have the E3L and the U.22. And if you don't believe me, you should go to the Sandisk booth and see it live in a server. I'm very proud of the Sandisk team. Many of you are here. Great job. But this didn't happen overnight, guys. Sandisk has been working on the Ultra QLC platform, which combines innovations like the customized controller, advanced system design, the Sandisk BiCS8 NAND, hardware and packaging innovations. We call it the Ultra QLC platform. Now, with these innovations, when you bring these together, you can see key metrics like 33% reduction in NAND data recycling. Think about the large capacity drives and the data sitting idle there. This becomes the most important metric. With this, on these drives, you can get the best performance at the lowest power and the highest endurance. Imagine a quarter of a petabyte drive. Think about the scaling at the data centers with it. But high-capacity drive, even with NAND scaling, comes with its set of challenges. At Sandisk, we are working on all of these challenges, whether they are to do with density, power efficiency, performance, or reliability. We are solving each one of them. That's our DNA. That's what we do to serve our customers with the right solutions. I'm not going to touch upon all of these constraints and challenges, but I'm going to talk about one. Like I said, even with the NAND scaling and the hardware and packaging innovations, it becomes very difficult to fit all the NAND and DRAM to get to these capacities. Now, the E.2 I showed you has shown us the line of sight to get to the 1 petabyte drive with 64 NAND placements. And Ross showed you the chassis, and we are glad to work with him in getting this E2 form factor there. But what about the other form factors? For instance, the E3L, which might not have enough real estate to scale to these capacities. Here, I'm proud to announce Sandisk is working on a new innovation called DRAM Lite, where our customers can enjoy optimum performance at these large capacities. Next, getting away from storage, I want to get to the compute side. Here, the key metric is IOPS per watt. The MLPerf sets the standard of GPU utilization here. I'm happy to announce our SN861 is available in all capacities, in all form factors, delivering best-in-class ML performance of 92% GPU utilization across 4 GPUs, which is awesome. But what is even more awesome is the graph on the right, which shows the million of IOPS at different power states. You can see the SN861 performs extremely well even at the lower power states. And guess what? It saturates at the 20-watt power state. What is more important here is a metric called performance and power efficiency, which is shown by the red dots. The SN861 beats the competitors by margins, but you don't have to believe me. Just go search for the Sandisk PPE paper, which is published, and dive right in. Now, you might think, is this the end? No. Obviously, Sandisk has the next generation of interfaces on its roadmap, and we are working tirelessly on them to meet or beat the elusive 100 million IOPS with one SSD. And we have them on our roadmaps. But we don't stop there. In this AI era, Flash needs more and more innovation. And for that, I would like to invite my esteemed colleague, the head of memory technology and CTO, Albert.
Thank you. Thank you, Manal. As difficult as it is to follow Einstein, I truly feel blessed to be here with you this year as well. So let's get going. In this part of our keynote, I will give you updates on our latest memory technology, HBF, or high bandwidth memory. We invented HBF to address the increasing gap between memory and compute capabilities, exacerbated by the ever-increasing demands that AI models put on the stagnant DRAM technology. This memory wall problem is manifesting itself as multiple challenges, both in the data center as well as edge applications. Current technologies try to solve this problem mainly by throwing money and power at this problem in the data center. And at the edge, frankly, there are just no good solutions out there today. So our answer to the memory wall problem is HBF, optimized for AI inference workloads. We designed HBF to deliver 8 to 16 times the capacity of HBM memory while delivering the same read bandwidth at the same price points. We envision HBF in the data center to complement HBM memory with the ability to attach terabytes of memory to the GPUs. And at the edge, we see that HBF can enable really sophisticated models that are today simply not possible from a perspective of power, performance, footprint, and most importantly, cost. So now that we are all caught up on HBF, let me just start sort of giving you a review of updates of what we've been doing since we introduced this technology about 6 months ago at our Investor Day. But let's start looking at some of the latest developments in the world of AI. And I have listed here some of the latest frontier models, LLMs, that came out recently. And a quick look at these models, you will see a few trends very quickly. First off, no surprise, in each generation of these models, the parameter size, the model size are growing very rapidly. The other one that's also equally important is that the context lengths are really increasing dramatically as well. That's sort of how much the model remembers of what has happened during your conversations with them and exchanges with them. So both of these trends are actually putting a lot more pressure on memory capacity, demanding higher and higher memory capacities. While this is happening, architectural advancements like mixture of experts are actually lowering the compute requirements for each token that's being computed. So this is a very interesting trend that we really, really like. This combination of more memory and less compute is giving rise to a very new paradigm that we call memory-centric AI. And we love memory-centric AI because HBF really shines in that paradigm. But new paradigms are never easy to establish. When we first introduced HBF, we have met some skepticism where people were really not seeing how a NAND-based technology could really meet the demands of AI workloads. We were getting comments like, hey, your latency is going to be too high, your write bandwidth is never going to match DRAM, or your endurance is not going to be sufficient. I think most of the people who made these comments were really thinking about the NAND in their SSDs. HBF is really not that NAND. It is totally reimagined technology with extreme performance compared to what you're used to from NAND technologies. Also, we came to realize that many people didn't fully understand how AI inference workflows operated. So to help with that information gap, we set up a simulation framework. And in this simulation, we are comparing two systems, identical GPUs, one utilizing HBM, another one utilizing HBF memory. And we're running a 400 billion parameter Llama 3.1 and looking at the performance differences. Of course, today, there are no GPUs with HBM that can run a 400 billion parameter model on a single device. Just doesn't exist. And then to solve the problem, people would essentially distribute a model across multiple GPUs and then sort of network them together and incur all the penalties of that inter-GPU latencies and whatnot. But we said, look, this is too complex. Let's give HBM an unfair advantage and assume that it can scale infinitely in capacity, so that what we're comparing is truly only due to the performance sort of differences between these two media. And here we have broken down the different stages of AI inference. Net, what we're seeing is that the performance difference between these two solutions is within 2.2%. Just a mere 2.2%. So this simulation setup is actually offered to you as a demo at our booth. And I would invite all of you to please go and take a look at it and hopefully convince yourself that HBF actually works awesome. Of course, as much as there were sort of skeptics, there also have been early adopters and innovators who jumped on in this great idea and created really fascinating concepts and ideas already within a short period of time. One such idea came from Korea, KAIST, and specifically Professor Jong-Uk Kim's group really worked on a new architecture proposal and showing how HBM and HBF could be used in tandem. In this case, Professor Kim's team is showing 100 gigabytes of HBM acting as a caching tier in front of 1 terabyte of HBF. And they show that with this solution, they're able to leverage all the advantages and improvements from HBF without a performance loss. KAIST calls Professor Kim the father of HBM. And we were really very happy to see this innovative and very capable group to start using HBF as an innovation platform. So this is fantastic to see. And speaking of innovation, I couldn't quite help and share with you that last night HBF was honored with the Most Innovative Technology award. And thank you. I apologize for the plug, but it was just too difficult to resist. Okay, let me go back to my updates. All right, during our Investor Day, we stated that we would form a technical advisory board for HBF. And a couple of weeks ago, we announced that two giants of computer architecture, Professor David Patterson and Raja Koduri, joined our board. Professor Patterson, thank you. I believe Raja is somewhere in the audience, if I can't quite pick up, but I welcome both. Of course, Professor Patterson, Party Professor Emeritus at UC Berkeley, a Google Distinguished Engineer and a Turing Award winner, needs little introduction. I'm sure many of you studied computer architecture from his seminal book, which is, like myself, which is considered a Bible in the area. And Raja Koduri, former EVP and chief architect at Intel and previously at AMD, is right now leading a really interesting and wonderful company called Oxmake. And Raja and his team have been really a dynamic part of our conversation around HBF. We truly, truly feel honored to have Professor Patterson and Raja sort of guide us in the development of HBF, as well as building an ecosystem around it. Building an ecosystem is really, really critical for any technology, any breakthrough technology like HBF. And we have from beginning on stated that we would really create an ecosystem that's standards-based, and because we felt that any breakthrough technology needs the infrastructure, the alignment, and the foundation to build on. To that end, Sandisk is extremely happy to announce today that we are creating a collaboration with SK Hynix to define a comprehensive industry standard around HBF. As you all know, SK Hynix has driven the adoption of HBM memory to a huge industry success. And there is no one better here to talk about that than Dr. Upyo Jang, Executive Vice President and Head of NAND Development at SK Hynix. Please welcome Dr. Jang to the stage. Dr. Jang. Welcome. Great to have you here.
Thank you, Alpo. Yeah, thank you. Oh, it's a really great to be here, especially with you.
Thank you.
Thank you very much. Yeah. So, when you look back the success of HBM before, it was not just about the spec only. I think it's just about the adoption also. So everybody could build on it at that time. Today, we see the same opportunity with the HBM. But in order to realize the possibility of the HBF, we need a kind of collaborative from now. So I believe that today is the first day of our collaboration. Yeah, thank you.
Thank you, thank you. Yes, indeed. This morning, we announced that our companies are aligning to define specifications and requirements so that HBF not only scales technically, but also commercially to exceed the expectations of our customers. Also, this partnership is going to lay the groundwork for HBF to become a true ecosystem with interoperability at its core.
Yeah, so we are excited to join forces with the Sandisk to create the standard. As you know, because the next generation of the AI cannot be built on the fragmentation. So we need a very excellent and strong foundation that everybody agrees on. Yeah, it just starts today. Hey, Sandisk. Let's do it together.
Sounds great. Sounds great. Thank you so much.
Thank you.
Sounds great. Indeed.
Yeah.
Indeed, our I think, partnership signals a deep alignment, and we're really looking forward to establishing a great partnership with SK hynix. Dr. Zhang, thank you so very much for being with us here. We really appreciate you coming down.
It's my pleasure.
Thank you.
Thank you.
Thank you.
Thank you. Thank you. Cool. Yeah.
Please. All right. Now, I think I'm about to enter the last slide here. The one question that we've been getting most since the introduction of the technology has been when. When are you going to sort of have HBF? A lot of people assumed, oh, is this the next decade, 2030s? So I'm, again, super excited to let you know that we are targeting to have the first HBF memory samples in the second half of 2026. And we expect the first inference devices using HBF memory, the samples of these devices, in early 2027. So you don't have to wait very long. And when thank you. And when these devices appear, we believe that they would be redefining the AI memory with massive capacity and minimal footprint. We're going to enable use cases from data center scale models to edge persistent personalization and establish a totally new paradigm around power, performance, and cost. I think it's going to be awesome. Can't wait. And as we are introducing Sandisk 2.0, we are bringing back our DNA of innovation and market making. And I'm really looking forward to have all of you join us in this exciting journey. Thank you all very much. Have a great rest of the day.